Hello everybody, this is Professor Jing with a brief overview of the basic concept of statistics. Here are the learning objectives for this lecture. First, be able to determine which statistical test will be appropriate for their proposed final technical paper. Second, be able to identify technical test for final technical paper. Third is to utilize different data collect method for the final technical paper. And last, identify data collection method and statistical research evidence. First of all, what are statistics? Statistics are a set of mathematical procedures used to organize, summarize, and interpret information. Statistics are the primary form of analyzing and interpreting data collected through quantitative research study. In this context, statistics help us to organize and understand the information contained with the data, communicate our result and characteristics of our data to the other, and answer the research question that derive research or motivate us to collect the data in the first place. Statistics allow us to draw inference about a body of data when only a part is observed. When we conduct research, we typically have to choose a sample from which to collect the data. So it is important to understand how population and samples differ. A population is the entire group that we're interested in, and they include all the members of whatever target group were specified. For example, if we say that we are interested in studying the political view of men, we are implying that we are interested in the view of all men. Similarly, if we want to study how men and women differ in political views, then we're interested in both entire population of men and the entire population of women. A population can be quite large or very small. The key to remember is that the population includes all members of the group. It is the responsibility of the researcher to specify who their target population is, and to do so in such a way as to let the reader know how general or how specific that target group really is. Because the population can be so large, we typically rely on the sample when we conduct research. A sample is a subgroup of unit or an individual from a population that we wanted to study. This small group is intended to represent the large group from which it was joined, and this smaller group is called a sample. Researchers have various reasons to use sample, but generally boil it down to not having the resource to collect data from entire population. Using statistics, a researcher can collect data from a sample, analyze those data, and then generalize those findings to the population from which the sample was selected. The figure illustrates the relationship between the population and samples. We begin by selecting a population of interest. Then we sample from the population, collect data from the sample, analyze the data, and generalize those results back to the original population. There are several different categories of statistics. The most important distincts are between the parameter and statistics, and between the descriptive and inferential statistics. A parameter is a calculated value that describes a population. A statistic is calculate the value that describes a sample. For every parameter, a corresponding statistic can be calculated for the sample. For example, we could calculate a mean for a population if we had the data from everyone in the population, and we can calculate a mean for the sample taken from that population. While corresponding parameter and statistic have the same meaning practically, they are technically different because they are calculated differently and different notations are used to refer them. Another important distinction that should be made is between descriptive and inferential statistics. Descriptive statistics are procedures used to summarize, organize, and otherwise simplify the data. Inferential statistics, on the other hand, are procedures that allow us to analyze the data from a sample and make generalization or draw conclusion about the population from which the sample was drawn. Hypothesis testing, confidence intervals, regression analysis, analysis of variance, and chi-square test are the example of inferential statistics tools. There is, however, one important disadvantage when it comes to using a sample. Even when every attempt is made to draw a random sample so that it will represent a population, odds are that it does not constitute a perfect microcosm of the population. Because of this, we have to accept that every time we analyze data from a sample instead of a population, we're introducing sampling error. Sampling error is the discrepancy or amount of error that exists between statistic that is calculated for a sample and the value of corresponding parameters for the population from which the sample was drawn. So, how to draw a sample from a population? Researchers use various different approaches to identify the people they want to include in the research. Researchers use two major sampling techniques, the probability samplings and non-probability samplings. Probability sampling is also referred to as random sampling or representative sampling. The word random describes the procedures used to select elements from a population. When the random sampling is used, each element in the population has an equal chance of being selected or no probability of being selected. The sample is referred as the representative because the characteristic of properly drawn sample represent the parent population in all ways. Non-probability sampling is a method of selecting units from a population using a subjective method. Since non-probability sampling does not require to complete survey frame, it is a faster, easy, and inexpensive way to obtain data. However, in order to draw a conclusion about the population from the sample, it must assume that the sample is representative of the population. It's always a risky assumption to make in the case of non-probability sample due to the difficulty of assessing whether the assumption holds. Voluntary sampling. The respondents are only volunteers in this method. Generally, volunteers must be screened so as to get the set of characteristics suitable for the purpose of survey. This method can be subjective to large selection bias, but is sometimes necessary. For example, for ethical reasons, volunteers with particular medical condition may have to be solicited for some medical experiments. Another example of volunteer sampling is caller to interview when an issue is discussed and people are invited to participate to express their opinions. Only the people who care strongly enough about the subject one way or the other tend to respond. The silent majority does not typically respond, resulting in a large selection bias. Volunteer sampling is often used to select individuals for focus group or in-depth interviews. Convenience sampling. Units are selected in an arbitrary manner with little or no plans involved. This sampling strategy assumes that the population units are all alike. When any unit may be chosen from the sample, the example is the Vox Pop survey, where the interviewers select any person who happened to walk by. Unfortunately, unless the population units are truly similar, selection is subjective to the bias of interviewer and whoever happened to walk by at the time of sampling. Snowball sampling. Suppose a researcher wished to find a rare individual in the population and already know the existence of those individuals and how to contact them. One approach is to contact those individuals and simply ask them if they knew everyone like themselves, then contact those people, and etc. The sample grows like a snowball rolling down the hill, hopefully include virtually everybody with that characteristic. Snowball sampling is useful for rare or hard-to-reach populations, such as people with disabilities, homeless people, drug users, or other persons who may not belong to an organized group, or such as musicians, painters, and etc. Quota sampling. This is one of the most common forms of non-probability samplings. Sampling is done until a specific number of units or quota for various subpopulations have been selected. Quota sampling is a mean for satisfying sample size objective for the subpopulations. The quota may be based on the population proportions. For example, if there are 100 men and 100 women in the population and a sample of 20 are to be drawn, 10 men and 10 women may be interviewed. Quota sampling can be considered preferred to other forms of non-probability sampling because it forced the inclusion of members of different subpopulations. Quota sampling is somewhat similar to stratified sampling, which is probability sampling in the similar unit that group together. However, it differs in how the units are selected. In probability sampling, the units are selected randomly, while quota sampling, a non-random method, is used. It is usually left up to the interviewer to decide who to sample. Contacted units are unwilling to participate are simply placed by the units that are, in effect, ignoring non-response bias. Compared with stratified sampling, quota sampling is relatively inexpensive and easy to administer and has the desirable property of satisfying population proportion. However, it has potentially significant selection bias. As all other non-probability sample designs, in order to make inference about the population, it is necessary to assume that persons selected are similar to those who are not selected. Such strong assumptions are rarely valid. Conceptual definition is how we define something. It is a foundation of your research question because you must know what something is before you study the impact. For example, improve mental health for the senior with isolation and depression. Operational definition is how we measure the variable. This is what you would typically think of when asked about the relationship between research and the research question. It relies on the conceptual definition. For example, how do we measure the mental health? Scores on the depression scales, and etc. Let's talk about collection methods. First, let's talk about document review. So you can review the documentation to gather information. You can review meeting minutes, sign-in sheet, quarterly or annual reports, or surveillance data to learn more about information you would like to collect. You can also review related scientific lecture or website to learn others' research studies or what results they found. This can help inform your research design. Type and source of data for possible use in practical evaluation or community health assessment include birth certificate, death records, hospital discharge, and license data. Observation gathers information. Example could be observing services being provided, training sessions, meetings, or special events. Observation done in abstractive manners can provide important information about what really takes place. It's important to decide what you need to observe before you collect the data by observations. It is helpful to make a checklist of things that you need to look for during the observation period. Survey allows data to be collected from a large group of people, and depending upon how the survey is administered, can allow people to remain anonymous. Survey instrument or questionnaire asks questions in the standardized format that allows consistency and the ability to aggregate response. Potential question can focus on collecting of qualitative or quantitative data. Conducting interview is a method that, like open-end question in a questionnaire, allow you to obtain an individual response in their own words. Interviews differ from questionnaire in that they list more detailed quantitative data that allow you to interact with the person to better understand their response. Interviews may be conducted in person or over the phone. Interviewing is useful when you want more in-depth information about person's altitude, knowledge, altitude beliefs, or behaviors. Like an interview, a focus group allows you to collect quantitative data. However, unlike interview, in which data are collected by one-on-one interaction, focus group provide data about a particular topic through small group discussions. Focus groups are an excellent method to obtain opinion about programs and services. They produce information from many people in a short period of time, so can be an effective method when information is needed quickly. When you are collecting data for your final research paper, you are going to land up with two typical data, categorical and/or numeric. These reflect different levels of measurement. Categorical data is the data that reflects characteristics or categories. For example, categorical data could include variables such as gender, ethnicity, education, and etc. In other words, categorical data is essentially a way of assigning number to qualitative data. Numeric data, on the other hand, reflects the data that are inherently number-based and quantitative in measure. For example, age, height, weight. In other words, these are the things that are naturally measured as number as opposed to categorical data. With each of these two main categories, there are two levels of measurement: categorical data, nominal, and ordinal. Numerical data, interval, and ratio. Let's look at each of those along with some practical examples. As we have discussed, nominal data is a categorical data type, so it describes qualitative characteristics or groups, with no orders or ranks between the categories. Examples of nominal data include gender, ethnicity, eye color, blood type. In all of those examples, data options are categorical, and there is no rank or natural orders. In other words, they're all the same value. One is not ranked above another. So you can view nominal data as the most basic level of measurement, reflecting categories with no rank or order involved. Ordinal data kick things up a notch. It is the same as nominal data in that it looks at the categories, but unlike the nominal data, there are also meaningful orders or ranks between the options. Here are some examples of ordinal data. Income level, such as low income, medium income, and high income. Level of agreement, strong disagree, neutral, agree, or strongly agree. You can see these examples, all options are still categories, but they are an ordered ranking between the options. You can numerically measure the difference between the options, but you can order or logically rank them, so you can view ordinal as the slightly more sophisticated level of measurement than nominal. As we discussed earlier, interval data are numeric data type. In other words, it's a level of measurement that involves data that is neutrally quantitative. Specifically, interval data has an order plus the space between the measure points are equal. Sounds a bit of fluffy and conceptual? Let's take a look at some examples of interval data. Credit score, which is from 300 to 850. GMAT score, which is from 200 to 800. And IQ scores. The temperature in Fahrenheit. Importantly, in all those examples are interval data. The data points are numeric, but the 0 points are arbitrary. For example, the temperature of 0 degree Fahrenheit doesn't mean that there's no temperature. It just means the temperature is 10 degrees less than 10. Similarly, you cannot achieve a 0 credit score or GMAT score. In other words, interval data is a level of measure that is numerical, but it does not have meaningful 0 point. The 0 is arbitrary. Long story short, interval type data offers more sophisticated level of measurement than nominal and ordinal data, but it's still not perfect. Let's talk about racial data. Racial type of data is the most sophisticated level measurement. Like the interval data, it has order, rank, and numerical distance between the points is consistent. But what it makes the king of measurement is that the 0 point reflects an absolute 0. In other words, a measurement of 0 means that there is nothing of that variable. Here are some examples of racial data. Weight, height, or length. Length of time or duration. In all of those examples, you can see that 0 point is absolutely 0. For example, 0 sounds quite literally means 0 duration. Similarly, 0 weight means weightless. It's not the same attribute number. It is what makes racial type of data most sophisticated level of measurements. With racial data, not only can you meaningfully measure the distance between the data point, you can also meaningfully multiply and divide by a certain value. For example, 20 minutes is indeed twice much time as 10 minutes.